Right. Technical debt is usually kind of a bad word or a bad pair of words in our industry. So today I'm going to be talking about how Peach Payments Engineering tackles technical debt whilst still trying to deliver strategic features and business growth. I'll go through an agenda briefly and talk a little bit about who Peach Payments is, my current employer, and what it is we're trying to do. And then I'll show some examples of what's going on. So my name's Sven. I'm currently a senior DevOps engineer at Peach Payments. I've been fiddling with stuff in a DevOpsy way for about 20 years, and about 10 of those I've spent in fintech. I'm also a husband and a father of 2 young daughters. And as Rob mentioned, I'm currently living in Cape Town in South Africa, which is where Peach Payments has its head offices. The agenda for today's conversation is going to be fairly straightforward. I'm going to go through a little brief history lesson, talking a little bit about Peach Payments, where it came from, and the sort of how we got to technical debt, or what technical debt exists for us. Then I'm going to talk about what I think technical debt actually is, and generally how it's presented in the industry. And then from there, I'll go through some examples of what we're doing to work with that, and then wrap up with some final thoughts and some kind of takeaway key points from the conversation. There's a fair amount to get through, so I'm going to go through this quite quickly. But yeah, hopefully it'll all be fairly straightforward. So, brief history lesson. Peach Payments is a leading payment gateway in Africa. We aim to provide a complete toolkit to help businesses accept, manage, and disperse payments through web and mobile platforms. And our mission really is to be the infrastructure layer upon which African businesses and entrepreneurs build and thrive. It's a pretty ambitious goal. And it's also a very, very highly contested space at the moment. I think if anyone's been paying attention to the fintech industry in general, you'll know that things in Africa overall are heating up very much at the moment, and there's a lot of interest in African fintech. And so we're in a fairly competitive space. Just as an example of how competitive that space is, we've seen revenue growth of over 650% just since 2020. Now, obviously, the impact of COVID-19 with a lot of businesses going online had a significant amount to do with that revenue growth. But our revenue growth numbers have been consistently very, very high. And so we've seen rapid growth, not just from a revenue perspective, but also from an organizational perspective in the last few years. And that's kind of where the wheels start to fall off a little bit. On the one hand, it's a good thing, but on the other hand, there are some challenges that come with that. So in the beginning, things were really simple. Peach was founded in 2012 and went through a brief incubation period at a Google incubator for about a year in 2013, 2014. And the initial product offering was a classic monolithic web app. The infrastructure was really simple. The code was relatively straightforward. There was a web front end on a server, and there was a database on a server. And that was kind of it. And one of the key things at that time was that all of the engineering was done by contractors. There were no staff engineers. There was no ownership of the software engineering at all at Peach at the time. But things grew. We got more customers, and we grew, and time went on, and we went from one contracting team to another contracting team, and contractors came and went. And a few years later, sort of around 2020, things were complicated, to say the least. We still had that initial monolithic web app, but there was also another web app or two, and there were about 500 Lambda functions, and there was a whole variety of database technologies. There was some NoSQL. There was some caching going on. There was some messaging happening. There was some queuing. We had various hooks and triggers and gateways and networks and blah, and blah, and blah, and blah, and blah. I mean, this is just like a fairly typical story, right? Things grow and things sprawl and things scale, and there's more and more and more. And we're not very good, I think, as engineers in general at taking away. We're pretty good at adding. It's what we're paid to do, right? And with this sprawl, all of this technology, came a bunch of other things like manual deployments, and there were no pipelines, and there was little to no automated testing, and there was little to no tracing, and there was little to no monitoring, and there was little to no alerting. There were pockets of these things, and depending on which contracting team had done which bit of work at which time, there were some things that were done really well and other bits that were left behind or not done at all. And these are kind of, you can start to see these are the beginnings and the sort of the birthing place of technical debt. It's like as you move and as you move quickly and as there's pressure to get features out and as growth is the sort of drum that everyone's beating, sometimes corners are cut, sometimes it's a lack of experience, sometimes it's just a lack of foresight, but for whatever reason, there's this growing amount of stuff that remains undone. And there are some key things that come out of this situation. And when you stop and look at it, if you look at Peach payments right in the beginning, and then you look at Peach payments circa 2020, you can see that there, if I took a snapshot of Peach payments in 2020 and I looked at the whole code bases around about when I joined, there was a lack of standards. There were no real naming conventions. There were a whole variety of different languages being used, programming languages. There were also different versions of those languages being used. There was different styles of testing, different testing frameworks, varying degrees of automation, some of it non-existent, some of it bash scripting. There were no real pipelines per se. And even down to like trivial little things like tagging. There wasn't a consistent way of tagging things, or there was just no tagging. So right from the really big things to all the small little details, there were huge gaps and inconsistencies. And there was also a lack of a paved road to production. The concept of the paved road being like the right thing to do is the easy thing to do. And so engineering teams, and at this stage, we'd now started hiring the first staff engineers, and we were still working with contractors as we are today. But we'd started hiring our first engineers. And so as people were being onboarded, they weren't really sure what the right thing to do was, and they weren't sure what the kind of approved way of doing a thing was. And so there were people kind of reinventing the wheel as they went. Everyone sort of found their own way of doing a thing, or the most appropriate way of doing a thing at that point in time. So there was generally this lack of consistency, and there was also a lack of shared awareness. So if you looked at components or even features or services as a whole, as individual things, there might be a good understanding or a deep understanding of a particular component or a feature or service, but there was no sort of global awareness of what was going on. There was no shared awareness of the entire platform, the entire system, or everything that went into it. And this led to a bunch of confusion and fear and uncertainty and hesitation. And generally speaking, there was a large cognitive overhead, a lot of thinking to be done about something that we felt should be easy. Things that we felt should be straightforward were becoming more and more complex to talk about and to think about and to plan for and to account for. And it was generally a relatively unpleasant space to be in, and not really from an organizational perspective, but from a technical perspective. It's not nice to be in a situation where you're not quite sure of what the right thing to do is, or you're not quite sure if something is going to work or not. And we know that this is a solved problem, right? There are good techniques for handling this sort of thing. But it's the implementation of those techniques and the actual execution of all of those right things to do that are really at question. And this is essentially what we consider to be technical debt. And so as a result of that inconsistency, there was a bunch of crisis management going on. We had system outages and service outages. There were a bunch of security risks that we were aware of, or that we became aware of over time. And it was, like that classic meme, this is fine. But actually it wasn't. And so when I joined at a very interesting time for Peach Payments. I joined when they were starting to onboard their engineering effort, to own their engineering effort. And I joined sort of right at the beginning of the bootstrapping of a DevOps sort of culture and movement within the organization. So I want to take a step back just for a second and talk briefly about what technical debt is. Technical debt is a concept. It's a metaphor for describing something. It's not really the thing itself. There isn't really a debt that we owe from a technology perspective, but it is a useful concept, and it's evolved from within the software engineering domain as a means to describe certain characteristics of software development in general. It was originally, the sort of idea of technical debt was originally attributed to Ward Cunningham, who was working for a financial institution at the time, which is why there's this link to the notion of debt and money and currency. And he's quoted as originally saying, if we fail to make our program align with what we then understood to be the proper way to think about our financial objects, then we were going to continually stumble over that disagreement, and that would slow us down, which is like paying interest on a loan. And so he was using the notion of paying interest on a loan as a way to describe the pain of constantly having to rethink about something that didn't map cleanly. And it's this cognitive load that is really key to the notion of technical debt. So the way I like to think of technical debt is that it encompasses everything which is not the way it ought to be, which is a pretty broad definition, but I'll explain a bit more in detail what I mean. So anything which isn't the way it ought to be and which causes cognitive overhead when thinking about or working with the system is what I consider to be technical debt. And the thing is, how things ought to be is part of a bigger conversation which has to be had beforehand, or at the very least has to be started at the beginning of dealing with technical debt. So when you're assessing or trying to overcome technical debt, you have to have this bigger conversation of how things ought to be. And a good example of this is if we agree internally as an engineering organization that manual deployments from an engineer's laptop is okay, then not having a pipeline is not technical debt. And I think that's important because it's very easy to get caught up in this notion that there's a perfect way to do things, or there's the way that everyone is doing things, and that's what we need to do because everyone's doing it. There might be good reasons for them doing it, and that's okay, but there also might be good reasons for you not to do it. And if you are constantly thinking that you should be doing something when in fact it's okay to not be doing that thing, then worrying about whether or not it's technical debt is actually the problem, not the technical debt itself. Perfect is the enemy of good. And so, like I said, this conversation, and it really is a conversation that you have to have with everyone, is so, so important. Before you get to dealing with technical debt, you've got to define what it is for you, and you've got to define what the parameters and boundaries of it are, and then you can really approach ways to deal with it more effectively. So I want to talk a little bit about some examples, and this is, specifically, I'm going to be talking about Packer and Terraform as just a couple of the tools that we've used internally to deal with and kind of overcome the technical debt that we have incurred over the last decade or so. These are mostly going to be from a DevOps or infrastructure perspective, just because that's where I work mostly. But this is by no means limited to just the infrastructure component or domain of the organization. This is a conversation that's happening across the engineering division. So let me just jump straight into it. So I'm going to talk first about Packer. We use it really for very straightforward things. It's not complicated. I'm not going to be doing any technical demo. We're using Packer to generate a standard AMI in AWS, essentially. There are one or two other things that we could use it for and do occasionally use it for, but generally speaking, we're using it to produce a baseline, a single location to update operating system choice, baseline of packages and utilities that are installed into the operating system. And this baseline includes regulatory and compliance components as well. So this is just a code sample. You can see we have a bunch of variables defined. This makes it relatively easy to pass in these attributes from a pipeline or from a shell environment, a command line, if that's how it needs to be invoked. But setting up a bunch of variables means that we can, in order to set up a bunch of variables, you have to talk about what something is called, and you have to talk about what thing is required. And so you can start to see there's already some of these conversational pieces being documented here in the code. You'll also notice there's a DD API key, environment variables. So even things like our choice of monitoring platform, these are things that we talk about, and then we can bake in and embed into the very baseline. So, when someone fires up an EC2 instance, for example, they've got there's a bunch of decisions that have been made beforehand that come pre-baked for them. And this is the beginnings of that paved road that I mentioned earlier. And this is also a way to preempt the introduction of technical debt by front-loading a certain amount of effort. You can ensure that when someone goes to make an EC2 instance, they're not randomly selecting from a bunch of different operating systems. They're not randomly selecting an instance size. And so we can start adhering up front to building things the way they ought to be built based on the agreements that we've already made. And I mentioned briefly compliance and regulatory stuff. So we actually use Ansible for that. Packer's ability to reach out to other utilities as a provisioning mechanism is really, really useful in this case. And so we have a bunch of operating system hardening that we do, and that includes components for our compliance and regulation frameworks that we have to adhere to for our industry. And so again, these things become baked into the utility from into the resource from the beginning. And it also means that they are located in a single place where we can go and make changes as those compliance frameworks get updated, or as the regulatory requirements get updated. We can go to a single place and update them, as opposed to having to do it all over the place. I mentioned that we also use Terraform. We use Terraform in preference to CloudFormation, simply because we are in fact multi-cloud. We run some workloads in GCP and we run some workloads in AWS. Terraform is great for a bunch of reasons. Composability is one of them. Composability and reusability. I think in previous talks we've had today, there's been mention of the fact that modules are a very, very powerful feature in Terraform, and they allow us to make infrastructure from pre-baked pieces very, very easily. It also provides a standard deployable unit of infrastructure. And by that, I mean something that all engineers can accept and be comfortable with and be aware of. And with that comes a standard interface. So there's, if you design your modules correctly, you can essentially produce an interface for customization. So you can compose different modules to create a thing, and then that thing can be customizable for a specific use case through the use of variables. And this is a very, very powerful way of building up infrastructure and allowing people to access those kind of decisions that you've already made, and so use the right things at the right time when building components for their needs. So yeah, just continuing on, this is again a simple sample of Terraform code. We have a source file here, which is actually the definition of a module. You can see that this module inherits from an existing module. So someone has gone through the effort of making an EC2 module, and then this workload runner module inherits from that. So a bunch of decisions have been made. We're inheriting from those decisions. You can see that this also inherits from the standard AMI that we produce in Packer. So we know that when this runner instance gets created, there's a whole bunch of thinking that's gone into it already. And so any engineer can come along and use this and be certain that they're getting a baseline standard of quality and a certain expected amount of behavior and everything else kind of baked into the product. And that's really, really useful from a technical debt perspective, because it means they don't have to remember to do that stuff, and they don't have to think about or worry about whether that is the right stuff. This module here is an instance of a runner workload. You can see here that we've got some things that are kind of configured, and there are a couple of variables that are available in this sample of the code. This then becomes the customizability interface. So this presents a really straightforward number of choices for someone to make, and they don't have to think about, oh, well, what does it mean to like include a VPC or a subnet, or, you know, what does it mean to worry about ingress, or like what instance type can I pick or can't I pick, et cetera, what monitoring should I have? Like, we've baked all of that stuff in. And I know I'm repeating myself, and I feel like I'm flogging a dead horse a little bit, but this really is very, very important. So if you're going to be thinking about technical debt, you've got to start looking at ways of eradicating it upfront by front-loading good behaviors and good decisions. And tools like Packer and Terraform, as people have mentioned before in talks earlier today, are really useful and powerful for this kind of thing. So I want to wrap up quickly. I'm cognizant of time, and I want to just talk about some final thoughts. You know, what does this all mean? To give you an example, we've gone from 0 to 20 modules just in the last 2 years alone. Now, the number 20 doesn't sound like a lot, but to come from 0 kind of Terraform implementation to 20 modules that can be reused and composed with other modules to create infrastructure is a significant amount of leverage that we can apply to eradicating the technical debt and preventing technical debt in the future across our infrastructure. We've also got we've gone from 0 to like over 40 projects that use Terraform in particular for the creation of infrastructure. And this is significant as well, because it means we went from having no automation of our infrastructure to having a significant number of our projects that rely on that infrastructure automation very heavily. And it's baked in from the beginning. So now we have 40 projects that from a technical debt perspective, we can say have little or no technical debt. And it's not just because they use Terraform that they have no technical debt, but it's because they use Terraform in the way we say is the right way to do things. And that, again, is an internal conversation, and you need to have it with your engineering folks, and you need to talk about what the right thing for you to do is. But it means that we have 40 projects that we don't need to really stress too much about, where there's a consistent way of conversing about them. There's a consistent thinking that goes into them. There's a lack of that cognitive overhead that comes when dealing with that project, because you just know that things are a certain way, and that's the way they're going to be. And what this has meant for our team and for our business is that certain tasks have gone from taking a day to complete to taking an hour to complete, because we don't have to have those conversations every single time we implement something. We don't have to argue about it. We don't have to talk about it. We don't have to consider the options every single time. And a bunch of stuff is pre-baked in for us, so we don't have to repeat those tasks. Repetitive, commonly performed tasks, things like adding users to systems, or standing up infrastructure in a development environment or a test environment, or handling security concerns like security groups or, things like that. These things, it's like death by 1,000 cuts. If you don't have this stuff defined up front, or if there's a different way of doing things, or if there's a significant amount of technical debt involved in doing something, then you're going to feel that pain on a daily basis. And again, coming back to Ward Cunningham's example, that's like paying debt on a loan. We also have better security as a result. Because we can preload a bunch of these things and predefine a bunch of security guidelines and controls. We have better visibility. We have greater certainty that we're doing the right thing from the get-go. And as you saw, we can bake in our compliance and regulatory frameworks from the start. And this results in a faster path to production. We get to production faster because there's a smoother ride and there's less talking and concern and wondering about things as we go. And then maintaining things in production is a bit more straightforward as well, because there's a consistent way of dealing with these things. There's a consistent interface to everything, and there's consistency in the thinking and in the decision-making that goes into all of these components. So, like I said, I'm aware of time. I'm a little bit over. I want to thank you very much for your time and attention. I hope you got something out of this presentation. If nothing else, I hope you were provoked into thinking a little bit about technical debt in a slightly different way. And if there are any questions, feel free to drop them into the chat or reach out to me if you want to discuss these ideas further. Thank you very much for your time and attention.